All right, in this video here, we're going to be looking at the graphs of parent functions. Now, what we call parent functions are graphs of basic types of functions, like a linear function or a quadratic function. Some of the other ones we'll look at: a cubic, square root, reciprocal, absolute value functions. So, what does the graph of that basic type of that function look like? And then we use these graphs of parent functions to do transformations of graphs. So, for instance, if I'm looking here, this is the graph of y equals x squared. I can use this graph to graph a transformation of that. So, like, what if it was negative x squared minus 7? Right? I can use what this graph looks like to graph that other one by just moving it around or flipping it over or stretching it or shrinking it or things like that. So when you're doing transformations of graphs and things like that, which is a bunch of videos that I'll be doing here also, the first step of doing or graphing a function using transformations is knowing what the parent function looks like. All right, so in this video here, we'll look at 6 different parent functions and what their graphs look like, and then you can use those to do the transformations of graphs. All right, so the first type of function here, the linear function, the most basic type of linear function is y equals x. And y equals x is just a straight line, right? It's like a diagonal line that goes through the origin. And some of the key points on the linear function are -1, -1, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, y equals x. So any point where the x and y coordinates are exactly the same is on this line y equals x. All right, so that's the basic linear function. And then when you do transformations of the graph, it moves it up or down or tilts it one way or the other. So that's the basic linear function. Right? The basic quadratic function, y equals x squared. Right? That's the most basic type of quadratic function you can have. The graph of that is a parabola, right? And some of the key points on that parabola, first 0, 0, the vertex of that graph is at the origin, 0, 0, and then we have the points 1, 1, and -1, 1. And to get these points, if you ever forget what those points are, to just kind of recall them really quick, just say, well, when I plug in x equals 0, 0 squared gives me y is 0, so 0, 0. When I plug in x equals 1, 1 squared is equal to 1, so it's the point 1, 1. When I plug in x equals 2, 2 squared equals 4, so it's the point 2, 4. Right? So, you should know what these points are when you're dealing with the parent functions and doing the transformations of the graphs. But if you forget them, you can just even mentally real quick, let me plug in x equals -2. -2 squared is positive 4. There's my point, -2, 4. All right, so it's important to know with these parent function graphs, not only the shape of the graph, like knowing that x squared is a parabola that opens upward, kind of like this, but also knowing some of the points on that graph so that when you do transformations, like if I have to shift this graph to the right 5 units, well, basically all I do is just take each point and just add a 5 to the x coordinate, and it moves over 5 units to the right, or it moves down a certain number of units and things like that. And like I said, I'll be doing videos about those transformations too. But to do those transformations, you need to know some of these points on the graph so that you can transform them and translate them to new points correctly. All right, so this is the linear and the quadratic function. Some of the key points on there. Right, and if you don't know these, if you're not familiar with the graphs and familiar with the points, you should study them a little bit before you get into the transformations of graphs, because it's really important to know. All right, I'm going to pause the recording here, erase these two, put up the next two, and then talk about those. All right, I got the next couple of functions up here. The next one is the cubic function, y equals x to the 3rd power. All right, so the basic graph of a cubic function looks like this. It goes down in the 3rd quadrant, it rises. It curves as it goes to the origin, and then curves back up, and it increases quickly in the 1st quadrant. All right, so that's what the basic graph of the cubic function looks like. Some of the key points on that graph, well, it goes to the origin, so the point 0, 0, the point 1, 1, and -1, -1, the point 2, 8, and -2, -8. Those are some of those key points on the graph of that cubic function. And again, just like with the quadratic function, if you forget the numerical values of some of those points, you can just plug in x equals 0, 0 cubed gives you 0. Plug in x equals 1, 1 cubed gives you 1. Plug in x equals 2, 2 to the 3rd power gives you 8. So you can get those x and y coordinates just by plugging in some numbers for x and then getting the y's. But if you have to do that too often, it starts wasting time, especially if you're like trying to take a test or something and you have to do these types of things. Better to just know those points than to have to plug the numbers in and figure those out each time, because like I said, that's kind of a big time waster. So that's the basic graph of the cubic function with a few of those key points on there. The next one, the square root function, y equals the square root of x. All right, so that graph is only in the 1st quadrant. It starts at 0, 0. It starts at the origin, and then some other key points are 1, 1, 4, 2, 9, 3, right? Notice the x values that I have on here, those are numbers that you can take the square root of, right? So the square root of 1 equals 1, right? The square root of 4 equals 2. The square root of 9, if I plug that in for x, equals 3, right? So the numbers on the square root function are a little weird. It's not just like 0, 1, 2, 3 like some of these other functions we have. It's 0, 1, 4, 9 for the x values, because those are the ones you can take the square root of, right? The square root function, basically, if you take the parabola, right, the y equals x squared that was up here a couple minutes ago, if you flip it over on the side and just take the top half, that's that square root function there. All right, so those are the key points of the square root function. Again, knowing what the graph looks like, and then also knowing some of the coordinates of those points so that you can do translations, moving it up or down or left or right. I don't know if my hand movements there match the words that I said, but you get the idea, right? Moving those graphs around. If you know what those points are, all you have to do is just change those points to something else, or just change the x values or change the y values to get the new points of your transformed graph. All right, so those are the cubic and the square root functions. Again, if you're not familiar with those, you might want to study some of these, what these graphs are and what those numbers are for those points. They are important to know. All right, we got 2 more, so I'm going to pause the recording again and then put up the last 2 and then briefly talk about those as well. All right, last couple of functions up here. We have the reciprocal function, y equals 1 over x, right? Remember, reciprocal means flipping over the fraction, so it's the reciprocal of y equals x, y equals 1 over x. The graph of that looks like this up here, right? That's the graph that's only in the first and third quadrants, and it's a curve. So it approaches the x-axis here, it approaches the y-axis up here, and then curves down and approaches the x-axis. In the third quadrant, it's close to the x-axis up here, and then it goes down and approaches the y-axis over here. Right, so that's the graph of y equals 1 over x, the basic shape of it. Some of the key points, 1, 1, 2, 1 half, 1 half, comma 2. And then the negatives of those in the third quadrant is basically the same numbers, but with both the x and the y made negative. So -1, -1, -2, -1 half, -1 half, -2. Right? And once again, you can get those values just like with the other functions. Like if I plug in x equals 1, 1 over 1 gives me 1. If I plug in x equals 2, 1 over 2, well, that's 1 half. If I plug in x equals 1 half, 1 over 1 half is 2 when you simplify that fraction. And then same thing with those negative numbers. Right, so that's the graph of the reciprocal function, y equals 1 over x. Some of those key points on there that you can use to do transformations of the graph. And then the last one we're going to talk about here is the absolute value function. Y equals the absolute value of x. All right, so the absolute value function, when you graph it, looks like the letter V, basically. It's basically 2 straight line segments. The one in the first quadrant is really just the line y equals x. It goes through the points 0, 0, 1, 1, 2, 2, right? Because the absolute value of 1 equals 1. The absolute value of 2 equals 2, right? So in that first quadrant, it's the same as that line we saw before, y equals x. Over in the second quadrant, however, for negative x values, it doesn't just continue the line y equals x. It's kind of like that line there reflected up into the second quadrant, right? So we have the points -1, 1, -2, 2, and again, if you plug the x values in, the absolute value of -2 is +2, right? The absolute value of -1 gives you that y coordinate of +1. All right, so that's the graph of the absolute value function with some of those key points. Right? Again, so for the parent functions, why this is important is because if I know what the graph of the absolute value function looks like, and if I know some of those points on the graph, if I'm asked to graph y equals 3 times the absolute value of x minus 2, I can use rules, which I'll talk about what those rules are in some other videos that I'm about to do. But I can use those rules and just take these points and say, all right, so that x minus 2, I have to add 2 to all these x coordinates here, and that 3 means I have to multiply all the y values by 3, and then I can plot those points and draw the graph of that new function based on the graph of this parent function. Right? So when you graph functions that are related to these 6 that we saw, though, the linear, quadratic, cubic, the square root, the reciprocal, and the absolute value, if you graph functions that are related to those, you don't have to start from scratch every time. You can use the graphs of these parent functions and then just do a little bit of tweaking to it here and there, adjust the x values this way, adjust the y coordinates that way to get the graph of that new function. Right? So that's what these parent functions are good for. So if you're studying transformations of graphs, it's important to know at least these 6. There are other types of functions and other parent functions that you may be required to know. For the class that I teach, these are the ones that we work with, so that those are the only ones included here. Right, so those are our parent functions. Know what the shapes are, know where those points are, it will help you when you do transformations of graphs, I promise. Oh, and if you thought that video was going to end there, didn't you? If you are interested in learning about the transformations of the graphs, I'm going to do some other videos where I talk about all the rules for like horizontal shifts and vertical shifts and stretches and shrinks and all that stuff. So check out those other videos I do where we use these parent functions to actually graph transformations.